Let's do some floating point addition. So the first thing we need to do is compare our two numbers and find which one has the smaller exponent, in which case it's this guy here, and we need to shift it such that they have the same exponents. So that means everything here needs to get shifted over by one place to make this 2 to the 3. So let's change this problem around, and we're going to have 1.110 times 2 to the 3. We're shifting this by 1, so that means we're going to have 0.101, right? Everything just shifted over and this 0 disappears. Because we're not going to add in any extra bits here. And that makes this by 2 to the 3. And now let's add these together. So this is just regular binary addition. We don't even really have to pay attention to that decimal there, at least yet. Right? We're going to drop it down and make sure we keep it there, but it's not too significant for our addition. So you got 0 and a 1, that's a 1. 1 and a 0 is a 1. 1 and a 1 is a 0 with a carry. 2 1s is a 0 with a carry. And we've got times 2 to the 3. Now, our last step is called normalization, meaning that we can only have a 1. We always just want a 1 on the left of our decimal point. And so that means we need to shift everything by one place. And so what we get is 1.001 times 2 to the 4th. Now, something to note is this 1 here, this guy, there wasn't any room to store it anymore, so it kind of got shifted off into oblivion. That's kind of the thing that we have to deal with floating point numbers, is in some cases, we can sacrifice exactness, or we have to sacrifice our exactness for some flexibility with how big our numbers can get. So this 1 gets shifted off into oblivion. If maybe this was had 6 decimal points or 6 bits for the fractional component, we might be able to save it. But in this case, since we only had 3, it gets shifted off and is gone forever. So that's just kind of the way this works. And it doesn't have to be big numbers, right? We can also do very small fractional numbers. We can have negative exponents. So the way this problem works is the same though, right? First we want to figure out which exponent is smaller so we can shift it. And remember, if it's negative, that means this -5 is smaller than this -3. So that means we need to shift it. We need to shift this guy 2 places that way, right? Shift it 2 places that way. And so what's that leave us with? That leaves us with 0.01110. So these 2 1s got shifted off into oblivion again. That's just kind of the sacrifice you have to make with our floating point numbers sometimes. And so this is times 2 to the -3, and this number stays the same. So it's 1.01100 times 2 to the -3. And now let's just go through and add them like normal, right? We just leave the exponents, so we've got, and we'll drop our period or our decimal point down here as well. 0 and a 0 is a 0, 1 and a 0 is a 1, 1 and a 1 is a 0 with a carry, 3 1s is a 1 with a carry, 1 and a bunch of zeros is a 1, and 0 and a 1 is a 1 times 2 to the -3. And in this case, we don't actually have to do our normalization step because we already have just a 1 on the left of the decimal point. Sometimes there never would be a case where we'd have a 0 here because of the way we already have things normalized. So, yeah, this is already done. That's what we finish with, is just that state right there.